In this video, we solve the logarithmic and exponential equations on page 3 of your section 5.3 lecture notes. And so we're going to begin with example 1G. And in this example, we have to solve the logarithmic equation log base 2 of x squared minus 3 equals 4. So we got to find the numbers we can put in for x so that the left-hand side is equal to 4. So on our logarithmic equation, right, you can see that 2 is the base and 4 is the exponent. And so in solving this, right, for every logarithmic equation, there's a corresponding exponential equation. And for every exponential equation, there's a corresponding logarithmic equation. So the base is 2, the exponent is 4. And so when we convert from this logarithmic equation to the corresponding exponential equation, we have 2 to the 4th power is equal to x squared minus 3. Okay. And now all we got to do is solve for x. You can see this is shaping up to be a quadratic. So 2 to the 4th is equal to 16. We add 3 to both sides, and we get 19 is equal to x squared. We switch both sides, we get x squared is equal to 19. And then we take the square root using the square root method. We take the square root of both sides, and we get x is equal to plus or minus the square root of 19. So there are two solutions to our original logarithmic equation. X equals minus square root of 19 is one solution, and x equals square root of 19 is the other solution. All right, now let's take a look at example 1H in your section 5.3 lecture notes on page 3. We're going to solve the exponential equation 2 to the x minus 1 power is equal to e raised to the 5x plus 3 power. And so there is some number or numbers we can put in for x on both sides that will make the left-hand side equal to the right-hand side. What is that number or numbers? Exactly, what is it? Well, 2 and e, right, are not a common base. So we cannot rewrite these exponentials on the left and right-hand side so that they have a common base, and then we can equate the exponents. We have to do something else in solving for x. And so we can use the natural log function. Since the left-hand side equals the right-hand side, we can take the natural log of the left-hand side, and that has to equal the natural log of the right-hand side. After doing that in this step, we can now apply the power rule to the left-hand side. We can bring this exponent x minus 1 on the number 2 down in front of the natural log function. And we have x minus 1 times the natural log of 2 on the left side. On the right side, we can use property 3 for the natural log function. The natural log and function and the natural exponential function are inverse functions of each other. So they, in a sense, cancel or undo each other. And so the right-hand side just simplifies to this exponent, 5x plus 3. And now we have a linear equation in the variable x, and we just use the rules of math solving this linear equation for the variable x. So first thing I did was distribute natural log of 2 inside the parentheses here, and I have x times the natural log of 2 minus 1 times the natural log of 2, or just minus the natural log of 2. Is equal to 5x plus 3. So I just distribute the natural log of 2 inside the parentheses here. And now I want to get this term with x in on the right-hand side on the left-hand side, and I want to move this real number, minus log of 2, to the right-hand side. So I'm going to subtract 5x from both sides, and I'm going to add the natural log of 2 to both sides. And when I do that, I get the equivalent equation x times the natural log of 2 minus 5x is equal to 3 plus the natural log of 2, right? I moved the 5x to the left side via subtraction, and I moved the minus log 2 to the right hand side by addition, okay? And this is what I ended up with. Now I can, on the left hand side, I've got two terms, and each term has a variable x in it, so I can factor out an x. And x times the quantity natural log of 2 minus 5 is equal to 3 plus the natural log of 2. And now, since this is a product, to isolate x on the left-hand side, I divide both sides by what's in parentheses here, natural log of 2 minus 5, and I get my solution to the original problem. This is the exact solution. X is equal to 3 plus the natural log of 2 divided by natural log of 2 minus 5. That is the exact value of x that makes the left-hand side equal to the right-hand side in our original problem. All right, so now let's take a look at example 1I on page 3 of your section 5.3 lecture notes. And we have the exponential equation 8 raised to the 2x plus 1 power is equal to 2 raised to the x minus 4 power. And so there is some real number or numbers that we can put in for x on both sides, and the left-hand side will equal the right-hand side. What is that number for x? Well, it turns out, right, 8 is equal to 2 cubed. So we can rewrite the left-hand side so that the left-hand side and the right-hand side have the same base. So 8 is equal to 2 cubed. So we have 2 cubed raised to the 2x plus 1 power. And now by the rules of exponents, right, to simplify this, you multiply the exponents. And so on the left side we have 2 raised to the 3 times 2x plus 1 power is equal to 2 raised to the x minus 4 power on the right-hand side. So the exponential on the left and the exponential on the right have the same base. So now we can equate the exponents. And so we have 3 times 2x plus 1 is equal to x minus 4 over here. Right? I equated the exponent on the left with the exponent on the right. So in solving for x, this now is just a linear equation. We distribute the 3 inside the parentheses, and I have 3 times 2x is 6x, 3 times 1 is 3, right? So the left-hand side is 6x plus 3. And now, right, I subtract x from both sides, subtract 3 from both sides, and I get 5x is equal to negative 7. And then when I divide both sides by 5, I get x is equal to negative 7/5. So minus 7/5 is the number I can put in for x on the left side and the right-hand side of our original equation, and the left-hand side will equal the right-hand side. All right, so now let's take a look at example 1J on page 3 of your section 5.3 lecture notes. And the exponential equation that we're going to solve is 8 raised to the 2x plus 1 power is equal to 3 raised to the x minus 4 power. So there is some number of numbers that we can put in for x, the left side and the right-hand side, that will make the left-hand side equal to the right-hand side. What are those numbers? Well, we cannot rewrite the left and right-hand side with a common base. So we have to do something else. And one popular approach is to use the natural log function. We can, since this left-hand side equals the right-hand side, the natural log of the left-hand side equals the natural log of the right-hand side. So in this step here, I'm taking the natural log of both sides up here. Now I can apply the power rule. This exponent, 2x plus 1 on the number 8, can be brought down in front of the natural log. And I have 2x plus 1 times the natural log of 8. Now remember, you got to put the 2x plus 1 in parentheses. If you don't do that, right, you won't do the multiplication correctly. And over here on the right, I bring this exponent x minus 4 down in front of the natural log. And I have x minus 4 in parentheses times the natural log of 3. So I apply the power rule to both sides of this equality. All right. So now I got a linear equation in the variable x, and we have to solve for x. So on the left-hand side, right, I distribute the natural log of 8 inside the parentheses. And on the right-hand side, I got to distribute the natural log of 3 inside the parentheses. And so when we do that, on the left-hand side, when we distribute the natural log of 8 inside the parentheses, we have 2x times the natural log of 8 plus 1 times the natural log of 8, which is just the natural log of 8. On the right-hand side, when we distribute the natural log of 3 inside the parentheses, we end up with x times the natural log of 3 minus 4 times the natural log of 3. And now I got to move this term with x in it to the left-hand side to go with this term with x in it, and then move the natural log of 8, which is just a real number, to the right-hand side to go with this term. So we're going to move this to the left via subtraction, and we're going to move the natural log of 8 to the right via subtraction. And when we subtract x times the natural log of 3 from both sides, we get 2x times the natural log of 8 minus x times the natural log of 3 on the left. And then when we subtract the natural log of 8 from both sides, on the right-hand side, we get minus 4 times the natural log of 3 minus the natural log of 8. Now on the left-hand side, we have two terms. Each term has the variable x in it, so we can factor out the x. When we factor out the x on the left-hand side, we have x times the quantity in parentheses, 2 times the natural log of 8 minus the natural log of 3, and then that equals the right-hand side from up here, minus 4 times the natural log of 3 minus the natural log of 8. And now to isolate x on the left-hand side, we divide both sides by this quantity in parentheses. And when we divide both sides by this quantity in parentheses, we end up with x on the left is equal to this fraction, minus 4 natural log of 3 minus natural log of 8 in the numerator, divided by 2 times the natural log of 8 minus the natural log of 3 in the denominator. And that is the exact value of x that equates the left-hand side to the right-hand side in our original exponential equation.